Is there a time before the beginning of time? This question, which goes beyond the boundaries of astrophysics and enters the domain of philosophy, was asked during an interview with Stephen Hawking, the British physicist who passed away in March 2018. The answer was quite simple. It doesn't make sense to talk about a time before the birth of the universe, Hawking argued, because time has always been present, although in a form different from what we humans are used to measuring. Let's try to understand. Let's imagine being able to press the rewind button on the time remote control until we reach 13.8 billion years ago. As we approach the beginning, the universe contracts more and more until it reaches the size of a single atom. In this ultra-compact grain of heat and energy, the laws of physics and time, as we know them, cease to function. In the imaginary journey back to the origins, the timeline thins out to infinity as the universe becomes smaller, never reaching a starting point. Before the Big Bang, time was folded, curved in on itself. It was approaching nothingness, but it was never nothing, Hawking explained. There was never a Big Bang that produced something from nothing. It only seems that way from a human perspective. In a previous interview on this topic, Hawking wrote, "Events before the Big Bang are simply not defined because there is no way to measure what happened at such events. Since events before the Big Bang have no observational consequences, they can also be cut out of the theory, and it can be said that time began with the Big Bang. Imagine a moment where the universe was so hot and dense that it seemed almost impossible for anything to survive. But from that infinitely small singularity, everything we know today was born. It was the Big Bang, a cosmic explosion that marked the beginning of the creation of the universe. But what was there before that moment? A question that has fascinated a generation of scientists, and it seems that everything was born precisely at that moment. However, thanks to the theory of the Big Bang, we know that before the explosion, the universe was concentrated in that infinitesimal point, the singularity. As the universe expanded and cooled after the Big Bang, the first subatomic particles, atoms, and stars formed. But the most extraordinary discovery of the Big Bang theory was the cosmic background radiation, unequivocal evidence of the primordial explosion. The Big Bang theory helps us understand the evolution of the universe, but there are still many unanswered questions. What is the dark matter and dark energy? How was the primordial singularity created? But despite these limitations, the Big Bang theory has given us a fundamental understanding of the universe and has paved the way for many exciting discoveries in astronomy and physics.